Okay, let us see how to solve this question. And this particular problem is based on telescopic series. Telescopic series. So what is telescopic series? Telescopic series is a series whose general term can be written as whose general term can be written as f of n plus 1 minus f of n, or we can say f of n minus f of n plus 1. Both are nth term of telescopic series. An example to an nth term of telescopic series. See, example, an is equal to 1 by 2n plus 1 minus 1 by 2n minus 1. If we call this particular term as f of n plus 1, we can call this as f of n. Why? Because in this f of n, if you replace n by n plus 1, we are getting this term. So it is of the form f of n plus 1 minus, it is of the form f of n plus 1 minus f of n, so that we can call it is an nth term of telescopic series. Okay, one more example to you. An is equal to 1 by n minus 1 by n plus 1. It is nothing but is very familiar to us. We might have seen a lot of places 1 by n into n plus 1. So nth term may not be always present in the form of f of n plus 1 minus f of n, or f of n minus f of n plus 1. That we need to understand, we need to express that. And if it is of the form, if we call this as f of n, we can call this term as f of n plus 1. So it is also nothing but an nth term of telescopic series. Now what will happen if you apply summation n is equal to 1 to n to an nth term of telescopic series? So this sigma n is equal to 1 to n f of n plus 1 minus f of n. Okay, if you apply summation from n is equal to 1 to n to the nth term of telescopic series, it is going to be f of n plus 1 minus f of 1. So here you will see terms are getting cancelled, so I am not going to the detail of that. So we should know that whenever any nth term is of the form f of n plus 1 minus f of n, if we take summation from n is equal to 1 to n, that is going to be f of n plus 1 minus f of 1. Yeah, now let's go back to our problem. Our problem is, if S is given to us, sigma r is equal to 1 to 50 tan inverse 2r by r raised to 4 plus r square plus 2, and the value of cot S is equal to 2552 by 425k, then the value of kx. So let us first find what is S. Let us first find what is S. So S is given as summation r is equal to 1 to 50 tan inverse 2r by r raised to 4 plus r square plus 2. Yeah. So in this case we can see that a summation is here. We are summing. So in this case nth term is nothing but tan inverse, you can call like rth term, tan inverse 2r by r raised to 4 plus r square plus 2. I have already told you this particular problem is based on telescopic series. So how do we write it as f of r plus 1 minus f of r4, or we generally will select f of n plus 1 minus f of n. In problem they won't give the nth term in the form of f of n plus 1 minus f of n. So we have to recognize and we have to write it in that form. Let us see. So I am going to be express this as f of r plus 1 minus f of r. So we know that r raised to 4 plus r square plus 2 can be written as r power 4 plus r square plus this 2 I'll write as 1 plus 1, and we studied that already. X power 4 plus x square plus 1 can be written as x square minus x plus 1 into x square plus x plus 1. Therefore this can be written as r square plus r plus 1 into r square minus r plus 1 plus 1. Then let us see this bracket of tan inverse. What is that? Now see, if 2r by r raised to 4 plus r square plus 2 can be written as 2r by r square plus r plus 1 into r square minus r plus 1 plus 1. Yes. And if you observe carefully here, the difference of these two terms, that is r square plus r plus 1 minus r square minus r plus 1, is nothing but 2r. So we will express the numerator is 2r. Okay, we will write 2r as r square plus r plus 1 minus r square minus r plus 1. If you subtract, you will get 2r, or 2r can be written in this way. Okay, divided by, so this 1 I will write first, is 1 plus r square plus r plus 1 into r square minus r plus 1. Now see, then here how do we write tan inverse? How can we write 2r by r raised to 4 plus r square plus 2? So it is nothing but tan inverse r square plus r plus 1 minus r square minus r plus 1 divided by 1 plus r square plus r plus 1 into r square minus r plus 1. And if we observe this, it is of the form tan inverse x minus y divided by 1 plus x into y. So that is nothing but tan inverse x minus tan inverse y. Therefore this can be written as tan inverse r square plus r plus 1 minus tan inverse r square minus r minus positive 1, tan inverse minus r plus 1. So as I told earlier, if you call this term as f of r, and in this f of r, if you replace r by r plus 1, it is going to be f of r plus 1. Now it is clear that it is of the form f of r plus 1 minus f of r. So what we have done here is, so we have expressed tan inverse 2r by r to the power 4 plus r square plus 2 as tan inverse r square plus r plus 1 minus tan inverse r square minus r plus 1. Now, so it is of the form telescopic series. Now let us find the summation. Now we have to calculate what is our S. Our S is sigma r is equal to 1 to 50 tan inverse 2r by r raised to 4 plus r square plus 2, which is equal to sigma r is equal to 1 to 50. So we have expressed tan inverse 2r by r raised to 4 plus r square plus 2 as in this way. Tan inverse r square plus r plus 1 minus tan inverse r square minus r plus 1. So we will write that here. So it is equal to tan inverse r square plus r plus 1 minus tan inverse r square minus r plus 1. So we need to apply sigma as I told. It is of the form f of r plus 1 minus f of r, right? So we are applying this sigma summation r is equal to 1 to 50 f of r plus 1 minus f of r, according to that idea of telescopic series. This can be written as f of 50 plus 1 minus f of r. From f of r plus 1, if we put r equal to 50, it is going to be tan inverse 50 square plus 50 plus 1 minus tan inverse 1 square minus 1 plus 1. So this is nothing but tan inverse 2551 minus tan inverse is 1. If we apply again tan inverse x minus tan inverse y, it is going to be tan inverse 2551 minus 1 divided by 1 plus 2551 into 1. So on simplification, use tan inverse 2550 divided by 2552. So we have calculated our S. So this is nothing but S. So we got the value of X. Now the question, it is given that cotus value is given as, cotus is 2552 divided by 425k. Then what is the value of k? So it is given that, cotus is equal to 2552 divided by 425k. So what is S here? So it is cot of tan inverse 2550 by 2552 is equal to 2552 by 425k. Yeah, so if we express tan inverse of cot, it will be cot of cot inverse 2552 by 2550 is equal to 2552 divided by 425k. From this cot and cot inverse gets cancelled, so 2552 divided by 2550 is equal to 2552 by 425k. These two are getting cancelled, which implies that 425k is equal to 2550. Therefore, k equal to 2550 by 425. So k is going to be, it is clear that k, the value of k is 6. So answer for this problem is 6.